Hello everyone, this is Team 1 and my name is Belle and we're working on a soldering helping hand. Soldering small or delicate components can be challenging with traditional tools which can lack precision and stability. Using a soldering hand can save time, improve precision, and provide a stable platform to hold components. It's also portable and adjustable, making it more convenient than traditional tools. The soldering equipment and supplies market has potential for innovation and differentiation in product features, design, and sustainability. The global market for soldering equipment and supplies was valued at $2.17 billion in 2020 and is expected to grow at a compound annual growth rate of 4.4% from 2020 to 2025. Thus, the electronics industry is a driving market due to the increasing demand for consumer electronics and automation and ease in creating innovations.
This was the initial concept drawing of the helping hands. It shows the PCB clipped onto the top of the device with 2 degrees of rotational freedom provided by some gear mechanism for both directions. In our second rendition, we realized the PCB would be better secured with a clamping mechanism. Additionally, we came up with the ball joint system for the arms, as can be seen in the sketch. Finally, we incorporated a flat platform at the table clamp to better interface with the work surface. In this third iteration, we detailed how the PCB holder would be secured onto the main body as well as how the gear interface would be incorporated. We realized after reviewing the drawing, the gear ratio should be reversed for fine adjustments. Finally, we also decided we would attach the ball joint arms to the main body via threaded screws printed onto one of the ball joints. The main edits seen in this final 3D model of the device are the reduced length of the neck, multiple attachment arms, replacement of the gear mechanism with a tightening knob, and a machine knob to secure the plate with a shelf feature to hold the PCB. There are 5 main components that make up the prototype: the main body, table clamp, ball joint arms, PCB holder base, and machine screw. We will now demo the functionality of each of these components. The adjustable table clamp mechanism allows the helping hands to be attached to any work surface. It is composed of a threaded rod, wing knob, and flat surface platform to interface with the table surface. Any variety of attachments, such as fume extractor, LED, or alligator clips, may be connected to the entire apparatus and accessed while soldering via the arms constructed by a series of ball joints. This allows for flexibility in attachment use and ease of adjustment while working. This wide U-shaped carriage at the top of the main body is where the PCB will be housed. It can be rotated towards and away from the user so the PCB may be accessed from different angles. It is secured to the body with another wing knob and threaded rod, which also locks the orientation of this PCB housing. The machine screw is the machine knob that creates a vice-like mechanism for the PCB to be held between the shelf plate, which is attached to the end of the screw, and the PCB housing, as shown in the last video. Now we will see a demo of the prototype in action. There are a few changes in terms of choice of materials and prototyping processes that we would make in the future. One issue that we encountered with our prototype is that the use of aluminum for the machine screw and knob is unnecessarily heavy and clunky. We can reduce the size of the knob and screw significantly, and potentially should consider having the knob itself be a light polymer, which the screw can be screwed into and secured with adhesive to prevent from falling off. In addition, we found that 3D printing threads is unsustainable, as stripping easily occurs over time when interfacing with a metal screw. We would want to incorporate threaded inserts into a future iteration. In terms of addressing scalability, we would want to leverage the use of manufacturing processes that are much more suited for large-scale production, such as injection molding.